The next slide here is just a reminder about domains, which are the x values, and square root functions, because we know that we only want to take the square root if we have a positive number underneath the radical sign. So here we have some color-coded graphs. So the first one is the domain if you have a negative in front of your square root. And remember, a negative in front means you are reflected across the y. So this means, or sorry, reflected across x. So you're reflected up and down. Okay. And then the original, I'm just going to really quick sketch what the original function is. And I'm going to choose, so I know the square root of 0 is 0. I know the square root of 4 is 2. And then I know the square root of 9, which would be off the graph just a little bit here, is about 3. So I can kind of give another point to sketch my graph accurately. So there's the parent function, and notice how the red function is reflected up and down. So since my black function, the parent function's on top, the red function just reflects down. And you can see that there, here we go up 2, here we go down 2. Okay. So there's our reflection if we have the negative out in front of the square root. And that doesn't change our domain because what's underneath the square root doesn't change. So we're still x has to be greater than or equal to 0. But if you put that negative inside the square root, what that does is it reflects it side to side, reflects across the y. So if you look at the blue function over on the graph, now instead of where the parent function is, which is black, which is on the right side over here, now we're reflected over to the side. So notice how we took this point and reflected it over. Okay. So that's what happens when you reflect across the y-axis if your negative is underneath the square root. And in that case now, notice how all the x values are negative. So that changes our domain because our x values changed. So our domain now is everything that is less than or equal to 0. And we can also do this algebraically. We've talked about the domain using algebra, anything underneath the square root. So if I take this, square root of negative x, anything under the square root has to be greater than or equal to 0. Well, if you solve that, we know there's a -1. So we divide by -1, and when we divide by a negative, our sign flips around. And so there's the algebraic way to show that exact same domain. So then algebraically for the last example, which is in green here, if I take what's underneath the square root and I say, well, that has to be greater than or equal to 0, so I subtract 2, so x has to be greater than or equal to -2, that matches up with my domain. But what does that look like on the graph? Well, this negative out front means it's going to reflect down, and this x plus 2 inside the parentheses means we're going to do the opposite of plus 2, so we're going to move to the left 2 units. So my green function over here should be flipped upside down, which it is, and it should be moved left 2, which it is now. Starts at -2, and it goes down instead. So just some things to keep in mind, some reminders of what those negatives do to our reflection, because now what we're going to do is practice a problem that is similar to one that you're going to have in your homework. And so you have this graph. They don't tell you the equation necessarily, but they give you the picture here. Okay? And so it wants you to adjust this based off of the changes in the equation. For example, letter A wants us to go and adjust it with the x minus 5 here. Well, this x minus 5 is in the parentheses, so this means we are actually going to the right 5 units. So all we need to do then for letter A is take all of our points and move them to the right 5. Now, in this program that I'm using to record, I can't copy and paste easily like you can in Notability. So if you're using Notability, you can graph this once and then use your cut and paste option and move it around. So the graphing shouldn't take too long. But also if you do this on paper or you do your homework on paper, it doesn't take too long either just to plot a few points. So what we want to do is we want to take all of these and move them to the right 5. So I'm going to go over 5, over 5. Okay, that's the idea that we're going to do. So let's see what that looks like. So instead of starting at 1, 2, 3, 4, 5, 0, instead of starting here, I'm going to move that over 5. 1, 2, 3, 4, 5. There's my new point. I'm going to erase, and you don't have to plot your first point like I did. I just like to for visual here. So I'm going to erase that one. Okay. And then instead of being at -3, 0, I'm going to move over 5. 1, 2, 3, 4, 5. Here's my new point. So then I can erase what's behind. So you kind of get the idea here. So there was a point at 3, 0. So I'm going to move over 1, 2, 3, 4, 5. There's that new point, and I can erase the old one, and so on. So my other two then were at -6, -4. So now I'm going to do instead -1, -1, 2, 3, 4. And then +6, -4. And if I have +6, I need to go over 5 more. So that's actually going to put me off the graph here a little bit, which is okay. Let's see where we get. To just be 1 over and then 4 down. 1, 2, 3, 4. So there's my other point. So we might go off the graph a little bit, which is fine, but there is every single point, and it's just shifted over 5 to the right. So that's for letter A. Letter B. We're doing 2 changes to letter B. We have the negative out in front, so this is reflecting down. And we're going to go up 3. So if we reflect it down, it's just taking everything and just flipping it upside down. So instead of starting at 0, +5, I'm going to start and have that point at 0, -5. So 1, 2, 3, 4, 5. But then I'm going to move it up 3. So 1, 2, 3. So you have to do 2 things. You have to reflect it and move it. So I'm going to, here, I'll just do this in 2 different colors. I'll do blue as my original and then, or blue as the reflected and then black as moving it up 3. So there's my up 3. Okay. Now, any points that are already on the x-axis, if you reflect them up or down, they do not change. So these 2 points, because the y value is already 0, that's not going to change. So -3, 0 and 3, 0 are going to stay the same. So -3, 0, that's my original, and it's the reflected. Because if you reflect that up and down, it doesn't have anywhere to go. So those 2 points are going to stay the same. Oop, I forgot to move up 3. So there's the reflected, and now my black moves up 3. 1, 2, 3. Sorry about that. So then same thing, if the +3 is reflected here, I have to move it up 3 to get my final transformation. And then the other 2 points were -6, -4. So I'm going to go -6, +4 and move that up 3. And then I'm going to do +6, +4 and then move that up 3. So my blue is my reflected, my black is reflected and shifted up 3, which is what we want our final answer to be. So there's different ways to go about the kind of the thought process here. You would not have to put what's in blue there. And especially if you can just copy and paste and turn your graph upside down on Notability, that's going to make this even easier. I don't know why I can't get rid of that blue one. There we go. All right, so there is our letter B, where we're flipped upside down and we're shifted up 3 after that. All right, letter C is 1/3 of f of x. So when that 1/3 is out in front, this means that you are changing the y values. You're taking 1/3 of f of x, and f of x is the same thing as y. So you're taking 1/3 of y, which is going to make the y value smaller. So this is what we call a vertical shrink, because the y values, which is the vertical axis, is getting smaller, so it's shrinking. So let's look at that, what that would be. So for letter C, our original ordered pairs, I'm going to write them off to the side. So the original ordered pairs were 0, 5, -3, 0, 3, 0, -6, -4, and -6 and then +6, -4. Okay. And then what we're doing now is we're going to take 1/3 times every y value. Our x value stays the same. Okay. So then our new ordered pairs, if I write that right next to it, would be 0 and then 5/3. And 5/3 is 1 and 2/3. So if that's an easier way for you to think about graphing it. And then when you multiply these two by 0, 1/3 times 0 is still 0. So these 2 points are going to stay the same because we're multiplying times 0, and that doesn't change anything. Okay, so now here we've got our -6, and then -4 times 1/3 is -4/3. Again, easier to graph that would be -6 and then -1 and 1/3. And then here, because the y values are the same, this would also be the same y value, but just +6. So I'm going to write it as -4/3 or +6, -1 and 1/3. So just writing out your new ordered pairs tells you exactly where you need to graph. So this one, it's a little bit more difficult to just copy and paste and move it around because you're changing the x or the y value. And in this case, we're changing all of the y values. So let's go ahead and graph these points. 0 and then 1 2/3. So 0, 1 2/3 will be close to 2. The -3, 0 and the +3, 0 stayed the same. And then our -6 was now -1 1/3. And our +6 was -1 1/3. So notice how it shrank going up and down. It's like I took it and I pinched it going up and down. It's not as high and not as low as it was before. So there is letter C. Now let's go ahead and jump around a little bit down to letter G, because letter G is like the opposite of letter C. Now the 1/3 is inside with the X. So the same rule holds true in terms of inside the parentheses. We do the opposite of what it looks like. So if we go back up to letter A, it says -5, but we know when we pull it out of the parentheses, it's actually a +5. So the same thing is true here. When we're in the parentheses, it says we're doing 1/3, which is like dividing by 3. But the opposite of that, when we pull it out of the parenthesis, we're going to multiply by 3. So we're going to multiply 3 times x. So just remember, in terms of rules, whenever you're taking something out of the parentheses, do the opposite operation. So in this case, instead of doing 1/3, which is dividing by 3, we're going to multiply by 3 because it's inside the parentheses. So for this, we're going to take all our ordered pairs, multiply the x value times 3, and the y value stays the same. So if we go, where are we going? Letter G. And if we rewrite all of our original equation, or our original points, sorry. And this time we're multiplying all of the x values times 3. The y values are going to stay the same. So the 0 would stay 0. -3 times 3 is -9. The y value stays. 3 times 3 is 9. Y value stays. -6 times 3, -18. Y value, stays as -4. And then 6 times -3 is +18. The y value stays. So now notice how the x values this time are what we multiplied times 3, and then the y values stayed the same. So now we're going to need to change the scale of our graph because we have the 18. So we can just go by 2s instead of by 1s. And if you do that, make sure you write your scale correctly. So for 0, 5, I'm going to go ahead right away and say this is 2, 4, 6, 8, 10. And then this is 2, 10. And I'm just going to do that in each direction so I remember that I'm going by 2s instead of 1s. All right. So my first ordered pair was 0, 5. So when I plot that, 2, 4, 5 will be kind of in the middle there. And then -9, 0, and +9, 0. And now -18, -4 would be, let's see, 10, 12, 14, 16, 18, -4, and +6, which turned into +18, -4. There we go. So there's our graph. Now remember we went by 2s, but there's what that would look like. All right, now the others, a little bit more basic in terms of our changes. Here we've got the negative on the outside, and so we're going to reflect it down. And then this -1 tells us we're going to go to the left one. So we're going to flip it upside down and move it over to the left one. So if we do that on letter D, I would flip upside down to 1, 2, 3, 4, 5 down, but then move it over to the left. and then get rid of that mark there. So I'm going to go ahead and just graph them and only put the final mark. So remember, on the x-axis it stays the same, so I'm just going to move it over 1 to the left, over 1 to the left, and then if we flip up and move 1 to the left, there we go. There you have, and just double check, because flipping it upside down and moving everything over to the left 1 unit. Couple more, letter E. Now letter E, the negative is on the inside. So remember, on the inside is when we reflect side to side. So if we do that, here's the original. I'm just going to graph the original for letter E. And there's our original. Now, if I move these side to side, I would like take this one and move it over to where this one is. So I would just like flip-flop those two. Because this is already symmetric across the y-axis, this is 3, this is 3, this is 6 down here and 6 down there, then it's not going to change. So because this is already symmetric to the y-axis, so I'm going to erase all those marks. I'm going to put my symmetry one back through. Okay, so let's just make a note on letter E. So this is symmetric across the y. So when reflecting side to side, it stays the same. All right, last one, letter F. Letter F, oh, nice and simple. We're just moving everything down 10. Okay. So that means we're going to go off the graph a little bit, but that's okay. So if I just take everything and move it down 10, my 0, positive 5 would now be at 0, negative 5. My zeros would now be at negative 10, which is right at the bottom. So 3 and negative 3. And then the negative 4s would be at negative 14. So I'm going to sketch this just down 4. And then if I go over 6 and kind of line those points up there, I'll be off the graph a little bit, but that is okay. So there's our graph if we shift it down 10. So there's a bunch of examples of different shifts. If you have any questions on those, as always, let me know.